Hello everyone, here's a video on the quadratic formula. You can check this out in chapter 5, section 6, of your textbook. This is probably something you've seen before, but we are going to go into it a little bit more in depth. So make sure you're ready to take notes, and here we go. So take a look at this slide. We've got the numbers 3x squared plus 5x plus 1 solved by completing the square. Whereas on the right-hand side, we have ax squared plus bx plus c equals 0. And we also solved that by completing the square. I want you to take a moment, pause the video, and compare the two sides of this. Perhaps you'd want to solve completing the square on the problem on the left-hand side, and then come back and try to solve completing the square, ax squared plus bx plus c equals 0. But either way, pause the video now, make sure this makes sense to you, so that way you can see where the quadratic formula came into play. I hope you paused it. Okay, so the quadratic formula, if ax squared plus bx plus c equals 0, then the solutions or roots or even zeros are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You could YouTube some videos of that. There are a couple of them out there that I know the songs. I hear you singing them in class, so you could go check those out, or we can sing them in class later, but I'm not going to sing right now for you. You can use the quadratic formula to solve any quadratic equation that is written in standard form, including equations with real solutions or complex solutions. So we can use it every single time we have a quadratic equation. So let's find the zeros of f of x equals x squared plus 3x minus 7 using the quadratic formula. So first of all, let's set it equal to 0. And we want to figure out which values are a, b, and c, so that way we can plug it into the quadratic formula. Well, if a is 1, b is 3, and negative 7 is c, we can plug it in as seen here. And then if you simplify, we'll get negative 3 plus or minus the square root of 9 plus 28 all over 2. And then just write it in its simplest form, and we get negative 3 plus or minus the square root of 37 all over 2. Always make sure that radical is in its simplest form as well. So here's another example, 3x squared minus x plus 8. So again, set it equal to 0. Figure out what a, b, and c are so that you can plug them into the quadratic formula, which here a is 3, b is negative 1, and c is 8. So then this time we'll have 1 plus or minus the square root of negative 95 over 6. That means we're going to have an imaginary number involved here. And then in the end we'll get negative 1 plus or minus the square root of 95 all over 6. But we would probably write the I in front of the radical. So, in the quadratic formula, underneath the radical, there is the b squared minus 4ac, and that is called the discriminant. The discriminant is part of the quadratic formula, and you can use it to determine the number of real roots of a quadratic equation. So you can figure out, just by looking at that, how many solutions and what type we're going to have. So, if the discriminant b squared minus 4ac is positive, then that means there are two distinct real solutions. If it is equal to 0, then there's only one real solution. And if it's less than 0, or if it's negative, so we'd have a square root of a negative number, that means we're going to have non-real or imaginary, so two distinct non-real complex solutions. By the way, make sure the equation is in standard form before you evaluate the discriminant b squared minus 4ac. And standard form is just ax squared plus bx plus c. So let's look at this one. Find the type and number of solutions for the equation x squared plus 36 equals 12x. So first we need to put that into standard form. So you have x squared minus 12x plus 36 equals 0. So b squared minus 4ac is negative 12 squared minus 4 times 1 times 36. So here the discriminant b squared minus 4ac is equal to 0. Therefore, this equation has one distinct real solution, so we'll have one real solution. For x squared plus 40 equals 12x, again, put it into standard form. Evaluate your discriminant. So here we'll have negative 12 squared minus 4 times 1 times 40. This time my discriminant is negative. Therefore, this one has two distinct non-real complex solutions. X squared plus 30 equals 12x. So again, put it into standard form. Evaluate your discriminant. And here the discriminant is 24, which is positive. So this one has two distinct real solutions. So here's another example where we again have two distinct non-real complex solutions when our discriminant is negative. So here's a graph and it shows related functions. So notice that the number of real solutions for the equation can be changed by changing the value of the constant c. X squared minus 6x plus 11 is in green. Then we have the plus 9 in red and the plus 7 in blue. So the blue has two distinct real solutions. The red has one distinct real solution, and the green would have two distinct non-real complex solutions. And that's it. Hope you took good notes, and I will see you in class. Bye.